Right, my dear children. Now, in the earlier chapter, we discussed several questions in your textbook. Now, it's time to do several extra activities, extra questions related to our lesson pressure. So, as usual, we'll be starting from MCQ questions. Right. So, you have to choose the most accurate answer from the given ones in here. Number 1. Correct statement about pressure occur due to gravitational force of the earth. It is a vector quantity. It is a scalar quantity. It is a force. Now, first one, it is mentioned in occur due to gravitational force of the earth. It's actually not relevant, right? Now, up to a certain extent, if you take the weight of an object, weight is getting created due to gravity, and due to that weight, a pressure is getting exerted, but that's a different case. Okay? So, like indirectly it's getting related, however, it's not directly getting related with the pressure. A kind of a way it's getting related, however, it's not that much accurate, right? Second one, it is a vector quantity, not at all, it's not a vector quantity at all, but however, it is a scalar quantity, my dear children. It is not a force either. This one is correct up to a certain extent, but however, the most accurate answer is third one. What is that? It is a good example for a scalar quantity. Okay, it is a good example for a scalar quantity. When you are selecting answers, you have to choose the most accurate or the correct one. So there can be several answers which has the, you know, like when you are reading it, if you go through with the lesson quite well, you might see that there is a certain kind of a relationship, but however, according to the question, according to the answer set, that answer might not be probable. So that's the case in here. So it's important to choose the most accurate answer from the 4 answers given. So the most accurate answer for the first question is, it is a scalar quantity. Okay, right then. Unit of measuring pressure. It's very simple, my dear children. Units of measuring pressure is newtons per square meter. Newtons per square meter. It should be definitely square meter, right? Newtons per square meter. That should be the unit of measuring pressure. Newtons per square meter. Next one, not a factor that affects pressure. Not a factor. So the 2 factors that affects the pressure is the force acting on the surface, and the second one is the surface area. So number 1, weight of object acting on a surface. It is given as weight of object acting on a surface. Weight is a force. So force acting on a surface. Correct. Perpendicular force, absolutely correct. Surface area of an object, correct. Length of an object, it's incorrect, right? Actually, that's also up to a certain level correct, because area is depending on the length and breadth. Okay, so length is a factor that depends. Area is a factor that depends on, depends the pressure, or that change the pressure. But however, there is another factor called the breadth. Length and breadth, both the factors are going to affect the area. So therefore, it's not directly related. So therefore, the answer should be the length. All of these 3 other factors are referring to a area or else to a force. So my dear children, the correct answer should be 4th one. Knife blade is made sharp to, you know that knife blade is made sharp to increase the pressure by decreasing surface area. So we'll go for the answer. Yes, here increase the pressure, right? Increase the pressure. Keep the pressure at a constant value, that is incorrect, right? We are making this thing to increase the pressure by decreasing surface area. The next one, pressure acting on a surface area of 60 square meters. 60 square meters. Pressure acting on a surface area of 60 square meters due to 120 Newton force. So it's really simple. P equal F over A. 120 Newton is the force. 60 square meters is the area. So 120 Newton division 60. 2 is the answer. So 2 newtons per square meter is our answer. 2 newtons per square meter. 2 newtons per square meter. This is Newton, my dear children. This is square meters. So answer is 2 newtons per square meter or 2 pascals. Right? The correct relationship is the correct relationship is really simple in here. 1 newtons per square meter is equal to exactly 1 of pascals. So that thing is given in the first answer itself, right? 1 Newton per square meter, not Newton meter or not Newton, right? Newton per square meter in m-2. Streamlined body shape of organisms. Streamlined body shape means this kind of a shape like they have in fish. So it has a like pointy head. So it allows to cut and travel through water, cut the water streams and travel through water quite fast, quite well. This point helps to increase the pressure. As it is like a pointed thing, it helps to increase the pressure. How does it increase the pressure? By decreasing the surface area, right? So pressure given upon water is getting very like pressure given by the body of the animal is getting very high upon water, so that it can pierce through water and travel quite fast. It helps for the locomotion. So this streamlined body shape of organisms helps to increase the pressure given upon water, right? So it increases the pressure. It increases the pressure. Instance where pressure is increased to make work easy. Instance where pressure is increased to make work easy. Making vehicle tires broad. So my dear children, if it is broad, right? If it is broad, broad means high surface area. So if it has high surface area, then the pressure is getting reduced. So this is incorrect. They are asking increased. Pressure increased. Applying grease on wheels, that's irrelevant. Making pointy iron nails, now that should be my answer. Making pointy iron nails, if it is point, if it has a point, then it would help to increase the pressure, right? We discussed this thing earlier also. It helps to increase the pressure. Next one, accurate meaning for pressure. The accurate meaning for pressure. Number 1, the amount of force exerted on a surface. Amount of force exerted on a surface. Now, if you take a surface like this, 150 Newton. Amount of force is 150 Newton. If you exert 70, then it is 70. So, amount of force exerted on a surface. Incorrect, right? It is incorrect. This one is referring to the amount of force. It is referring to the amount of force. Amount of force acting on a unit area is the pressure, not the amount of force acting on a surface. So, this is incorrect. Weight of an object, absolutely incorrect. It's not the weight. Mass placed on a surface area of the object. That is also incorrect. So my dear children, we can't get an exact answer. There is no definition. There is no accurate definition in here for the pressure. It's not the amount of force placed on a surface, right? Incorrect. It's not the weight of an object. Incorrect. It's not the mass which is placed on a surface area. No, incorrect. Then here you have to take the answer as none of the above. None of the above definitions are going to correctly match with the pressure. So therefore our answer is D. Next one. If you are walking in snow, why would you wear boots instead of high heels? So you know that high heels have pointed tips. Pointed tips means they are exerting a greater pressure. So if you walk on snow, especially girls, they're the ones who are wearing high heels, right? So if you walk with high heels, particularly on a snowy road or in a snowy land, what will happen? Definitely your legs will sink. So high heels exert a greater pressure as it has a pointed heel. So when you are walking on snow, you have to minimize the pressure. Not to increase, but to minimize. To minimize the pressure, you have to wear boots. Boots have larger surface area. So therefore it avoids sinking as it exerts a lesser pressure on the ground. So let's go for the answers. Boots have a higher surface area, making the pressure less and stopping you from sinking. Yes, that's the obvious answer. So next one, because it's more comfortable. No, it's not about the comfortable thing in here. High heels have a higher surface area, making the pressure less, right? High heels have higher surface area. That's absolutely incorrect. High heels have less surface area as it is pointed. None of the above. So our correct answer is A. Boots have higher surface area, making the pressure less and stopping you from sinking. Next question. Instance that highest pressure occurs. So there are 4 instances, A, C, B and D. So here you have to select the highest pressure. So in order to give out a higher pressure, the surface should have very less surface area. So choose the instance which has the very less surface area. Yes, my dear children, here you can observe the very less surface area contacting. So B should be our answer. The highest pressure occurs in instance B. Next one. Instance that lowest pressure occurs. In order to have the lowest pressure, right? In order to have the lowest pressure, my dear children, high surface area should contact. Okay? There should be high surface area. So high surface area can be observed in this figure, which is the figure D. Yes. Figure D is our answer. D is our answer. Right. Then the next one. Which of these animals would probably cause the greatest pressure on the ground? Which of these animals would probably cause the greatest pressure? That means the highest pressure. Which animal is going to cause the highest pressure? Number 1, fat cow with big feet. Fat cow, big feet. Cow is fat, exerting greater force. Big feet means broader surface area. So pressure is somewhat minimized. Let's go for the other one. Calf with big feet. Calf. Calf means, that's the child, right? So it has a lesser weight. Big feet, broader surface area. So very less pressure. Fat Cow with small feet. Cow is fat, larger size, larger the weight, higher the weight. Small feet, smaller the feet, smaller the broadness of the feet, smaller the feet, smaller the surface area. Fat with smaller feet. Fat means greater force due to greater weight. Okay. Smaller feet means smaller the surface area, smaller the contact surface area. So greater the weight, greater the perpendicular force. Smaller the feet, then my dear children, greater the pressure. So both the instances, both the cases are favorable to increase the pressure. So among these four, the greatest pressure is given out by fat cow with small feet. Then the calf, you know that calf has a less weight. So therefore, from these four animals, the best answer that exert a greater pressure is the third one, fat cow with smaller feet. Cardboard box weighs 30 Newton. If we added weight to the box, what would happen to the pressure? So, if you are adding weight to the box, you are increasing the perpendicular force, like from 30 to 50, 50 to 60, 60 to 90, and so on. When increasing the weight, the perpendicular force increases. Upon increasing the perpendicular force, my dear children, definitely the pressure is going to increase. So it is saying, yes, the pressure should increase. Pressure increases. Okay, it's not getting decreased, it's not getting remain the same, right? But it is getting increased upon increase in the weight, upon increase in the force, perpendicular force. Right. Which situation is used to decrease pressure? Decrease pressure. Decreasing pressure means we have to increase the surface area, or else we have to decrease the perpendicular force. Let's see. Having a sharp blade in a knife, incorrect. Having a sharp means we are increasing the pressures. We need to decrease. Cutting a soap bar with a thread, once again incorrect. Thread has a less surface area, so here we increase the pressure. Applying spikes on shoes, irrelevant, right? Making boots with a wider surface area. Wider the surface area, lesser the pressure gets. So answer is making boots with a wider surface area. Making boots with a wider surface area. Next one. A cardboard box weighs 30 Newton. Like in the earlier question, this cardboard box is going to weigh 30 Newton. If we reduce the weight, now we are going to reduce the weight of it. If we reduce weight of the box, what would happen to the pressure? Now in the earlier case, we increase the weight. Now in this case, we are reducing it. In the earlier case, pressure got increased. Definitely in this time, then the pressure should decrease upon decrease in the perpendicular force. So, decrease. Pressure decrease. Mass of an object is 5 kg. If this placed on a surface, pressure acting is 50 pascal. What is the pressure when mass is doubled? What is the pressure when mass is doubled? A good question, my dear children. So in the earlier lesson number 4, when we are discussing about the force, I told you that I told you how to convert actually masses into newtons, right? How to convert a mass into a Newton value means how to convert a mass into a weight. Even I have given you an example, 1 kilogram, a relationship, 1 kilogram of mass is equal to 10 Newton of a force. So if there are 5 kilogram, we can say that it's equal to 50 Newton, right? 50 Newton. Let's assume that the area which the object is contacting is equal to 2. Now in here then pressure is equal to 50 over 2. How much? 25. 25. Now what are you going to do? What is the pressure when mass is doubled? Now the pressure is, now we are doubling the mass. Doubling the mass means 10 kilograms. Means the Newton value, it would become to 100 now. So if you divide 100 by 2, my dear children, answer becomes 50. Earlier it was 25, now it has become to 50. See how the pressure is going to change. See how the pressure is going to change. I just assume that the contact surface is 2. 2 units, any units, right? I just assume that the area is just 2, any unit, whatever the unit you want. Because the area is not getting changed here, no? They are not mentioning about the area. So we can say that the area is not getting changed. Only the factor which is getting changed over here is the force. Force is getting changed from 50 Newton to 100 Newton. So if the earlier case, if the 50 Newton, then you divide P is equal to F over A. You know that P is equal to F over A. So when you divide 50 Newton by 2, answer is 25, whatever, Pascal or whatever. We will say that the pressure is 25 units. So when doubling the mass, you are going to double the force also. Why? Because when doubling the mass, weight is also going to double. So at this time then the new answer becomes 100 of newtons. So when you divide 100 by 2 units, the pressure becomes 50 units. Earlier 25, now it's 50. You can clearly see that the pressure is getting doubled. Pressure is getting doubled upon increase in the weight. So my dear children, increases, becomes half, no change in pressure, pressure is getting doubled. See, this is the correct answer. Increases correct, becomes half incorrect, no change incorrect. But the most accurate answer is pressure is getting doubled. As you can see here, I have calculated and showed you, right? Pressure is getting doubled. Exactly, the pressure is getting doubled upon doubling the force. Here we are doubling the force by doubling out the mass of the object. Right then. Length and breadth of a box is 10 centimeters and 5 centimeters respectively. If length is increased to 20 centimeters, what happens to the pressure? Length and breadth of a box is 10 and 5. Okay, right? So 10 and 5 means area becomes 10 times 5, 50. Let's say that, okay, it's given as square centimeters. Then in the second case, now we are increasing the length up to 20 centimeters. Then this is 20 times 5, becoming 100. So my dear children, here I have calculated the two areas of the two instances. In the first instance, it is 50. In the second instance, it is becoming 100. Now, they are not mentioning about the force. So, we can assume that the force is constant, like in the previous case. Okay. Now, let's see. Take the side somewhat up. Now let's see, my dear children, what's going to happen over here. Let's assume that the force is just, we'll take a somewhat, we'll assume that force is 200 Newton. I'm going to assume that the force is 200 Newton. Okay, 200 Newton is the force. And now you know that P is equal to F over A. So in the first case, force is equal to 200. This is the first case. This is the second case. In the first case, area is 50. So you divide it by 50 and see how much is the answer. 4. You don't need the units in here. We are just seeing what is going to happen with the pressure. That's it. So you don't need you don't need the units in here, right? So don't go for the units. Just calculate, substitute the values and see what's going to happen with the value, my dear children. They are asking only about the value, no? So let's see the value of the second one then. Number 2. Once again, P is equal to F over A. In the second instance, area is now 100. Force remains the same. Answer becoming 2. So earlier it was 4. Now it is 2. You can clearly see it. So the pressure has got halved, right? Pressure has got halved or pressure has got reduced. Let's go for the answers then. Decreases, that is correct. Stay the same, incorrect. Pressure is getting doubled, incorrect. Becomes half. See, it becomes half. This is the most accurate answer. It becomes half, my dear children. Right? Earlier it was 4. Now it has become to 2. Half of 4 is equal to 2. So it becomes half. So in these cases, you just take a certain value. Don't go for the units. Units are irrelevant. They are asking only about the value. What will happen to the value? Is it getting increased? Is it getting decreased? Is it becoming half? Is it getting doubled? Like that way. Asking about magnitude only. So just go for the value. Ignore about the units. If it is mentioning about the units, then you have to calculate and get the answer. However, they are not asking about the units, so they are just asking what kind of a process is going to occur over there. That's it. Okay. So we are not going for the units, but we are just mentioning what kind of a thing, or like by when you are considering the values, what sort of a thing has happened over there. That's it. So the thing which is happened over here is 4 has become 2. That means the pressure has become half. Okay. If the horse read up on 2 legs, what effect would it have on the pressure? Now you know that horse is going to see on the place on the ground, or he's going to use his 4 legs to sit on the ground. Okay. However, if it is running up by using 2 legs, then the contact surface area is reduced by 2 units. If it is getting reduced, then what would happen? Pressure is getting increased by how many? By 2 times. If the contact surface area is reduced by 2 times, pressure is getting increased by 2 times. So let's go for the answers. It will exert half the pressure it did before. Incorrect. It will exert the same pressure. Once again, incorrect. It will exert twice the pressure. Even in the earlier case, I have calculated and show you what has happened. Right? In the earlier case, I think you can remember, surface area got increased. Okay. Surface area got increased from 5 to 10. Right? from 50 to 100. In that case, my dear children, pressure got reduced by 2 times. Then in this case, pressure should increase by 2 times. Okay, that's the case. Select the incorrect statement. Pressure decreases when increasing force. So, pressure decreases when increasing force. It is incorrect. Pressure decreases when increasing weight of an object. Pressure decreases when increasing weight of an object. When increasing weight of an object, pressure decreases. Actually, we can't say that thing, right? We can't exactly say it. How come? Because we don't know whether we are going to keep this object on which kind of a surface, right? However, up to a certain level it is incorrect. Up to a certain level it is incorrect. So, I'll put incorrect in here. Pressure is increased when surface area is decreased. That is correct. That is correct. So, pressure decreases when increasing force. That is absolutely incorrect. Pressure decreases when increasing weight of an object, right? That is also incorrect. Pressure increases when increasing weight of an object. So, there are 2 answers which are incorrect. So, in these cases, my dear children, okay, in these cases, what do you have to do? Don't just read the question and if the answer is there in the first place, then don't go for that answer, just read the other options as well. There might be 2 or 3. So, in that case, the accurate answer will not be the one that you are thinking. Now, here there are 2 possible answers. Pressure decreases when increasing the force. That's incorrect, totally incorrect. In the second one also, pressure decreases when increasing the weight of an object. That is also incorrect. Okay, that is also incorrect because when increasing the weight, pressure is going to increase. Definitely the pressure is going to increase. So, there are 2 possible answers. In the third one, pressure is increased when surface area is decreased. So, we have to choose the incorrect answer. So, there are 2 incorrect answers over here. Okay, there are 2 incorrect answers over here. So, I'll mention both the incorrect answers. None of the above that cannot be taken as an answer because there are 2 incorrect answers. Okay. So, sometimes in some questions, this would happen very rarely, right? Sometimes in some questions, right? In some questions only. Sometimes in some questions only, these might come, but however, most of the times, you won't be giving out these types of questions. But very rarely, there can be occasions like this. Yeah, there can be 2 answers within the question. So, the children would think, oh, there are 2 answers. Both of these things are correct. So, might be the answer, actually the actual answer is not these 2 but somewhat different one. Then you go for the others. Like that way you might get confused. Okay, these MCQ questions are very tricky. So, in here I have given you 2 different answers, right? I have given you 2 different answers. All of these 2 are correct. A and B, both the answers are correct because it sets for the statement given in here above, incorrect one, right? So, my dear children, don't go for the others, don't go for the like none of the above things because there are 2 answers which are correct. Either way, all of these 2 are correct. So, I can underline, right? Or either of these 2, all of these 2 are correct. In these 2 are, at least one of these 2 are, okay? You have to don't do it like this. if you are given with a question, just underline 1. But however, second one is also okay for the question. Now, if there are 2 answers within your paper, these might come very rarely, okay? Very rarely, right? If there are 2 answers, don't highlight or don't underline both the answers. You have to choose only one. If you highlight or if you underline both the answers, then also you won't be given marks. Then also you won't be given marks. Okay? You just need to highlight only one. That's it. Okay? If there are 2 or 3, right? Actually the answers would come as most probably in these types of questions, if there are more responses which are correct, then you'll be having only 2. Okay, 2 is the maximum one. However, don't highlight the 2 answers. You have to highlight only one. There can be 2, but highlight only one. And don't go for the others. Like if none of the above are given, don't highlight that thing. That is incorrect, totally incorrect. No, because there are 2 answers. Okay. So if you are given with several responses, several correct responses, go for a 1. Don't highlight the 2. And don't go for the responses like none of the above is true. And like that way, don't go for those things. Okay. Because there are 2 answers which are correct. Remember to highlight only one answer, right? Tricky MCQ questions. Okay, then we'll go for the next one. Right, once again 2 tricky questions. Read it carefully. Number 1, which situation produces more pressure on the floor? More pressure, huh? They are asking about more pressure. Standing on 1 foot. So if you stand on 1 foot, all of your weight is going to bear by that one single foot. Let's imagine now they are saying that there are 4 feet snow. So let's imagine that this is an animal. Okay. So if an animal is going to stand on 1 foot and 2 feet and 4 feet, then my dear children, gradually the contact surface area is getting increased. In 1 feet, the pressure is the force acting, or the weight of the animal is placed on just one single feet, just one single particular area. In 2 feet, the pressure is distributed among 2 of the feet, which the surface area is getting increased. During the third instance, 4 feet, the pressure is exerted on all the 4 feet. So the pressure is divided among 4. So when the pressure is dividing, pressure is decreasing. So when the animal is on 1 feet, right? When the animal is on 1 foot, just 1 foot, what will happen? It will exert the greatest pressure on the ground. So the situation which produces the more pressure on the floor is standing on 1 foot. That should be our answer. In these cases, right, pressure is getting divided and pressure is getting decreased. Like in the vehicles, loaded trucks, we apply several tires to decrease the pressure by increasing the surface area. Same thing applies to here. Then the next question. Which situation produces more force on the floor? More force on the floor. More force on the floor. Huh? Remember. Standing on 1 foot, standing on 2 feet, standing on 4 feet, all produce the same. What can you say? So all of you guys might think, like in the previous case, same thing, no, same question is being asked. So answer is standing on 1 feet. Absolutely incorrect. Why is that? Answer for this question is this thing. All produces the same. Why is that? Because if the same animal is going to sit on by using 1 or 2 or 4 or 5 or whatever the feet, right? If the same thing is going to stand on whatever kind of a feet, whatever a number of feet, its weight is not going to reduce or increase, no. It produces the same weight. So it produces the same force, right? So it produces the same force. Earlier case they are asking about the pressure. This case they are asking about the force, not the pressure. So no matter how many feet that they are going to use, that the animal is going to use, or whatever the thing is going to use, weight is not getting changed. Weight is the force which is acting here. So if we assume that the weight of the animal is 50 Newton, in each of these cases, no matter the number of feet, 50 Newton is acting downward. So the answer is quite obvious, all produces the same. Right then. Next question, which of the following decreases pressure? Which of the following decreases the pressure? Snowshoes, pins, nails, ice skates. You know that ice skates increases the pressure, so it is incorrect. Nails once again increase, pins once again increase, snowshoes. To walk on snowshoes, to walk on snow we use snowshoes. If the pressure is increasing over there, then the person definitely will sink within the snow. So in snowshoes, we increase, right? We increase the surface area of the shoe to decrease the pressure. Student uses a glue stick with an area of 4 square meters, putting a pressure of 0.5 newtons per square meter on her book. Calculate the force she puts on the glue stick. Okay. So 4 square meters is the pressure, is the area, and the pressure which is exerted is 0.5. Then we need to calculate the force. So we'll apply P is equal to force upon area. Pressure is given 0.5. Force we don't know. Area is given. How much is the area? 4. So you multiply both the sides by 4. 4 to 4 is getting cancelled. Force is equal to here. 0.5 means half, no? So half times 4. Cancelled. Answer is 2. Force is measured from fundamental units, the Newton. So 2 Newton is our correct answer. So it's really simple. You just multiply both the sides by 4. Then here 0.5 times 4. Then 0.5 means exactly half. Then half times 4 is equal to 2 newtons. As we substituted it from fundamental units, like here newtons per square meter and in here square meters, our unit should be definitely newtons. So force is 2 newtons. Right. Calculate the area of a dart which hits the dartboard with a force of 10 Newton and pressure of 2000 newtons per square meter. 2000 newtons per square meter, 10 Newton of a force. So once again P is equal to force upon area. Okay, pressure is given how much? 2000 Nm minus 2 newtons per square meter, 2000. You can just simply substitute with the value without the units because it is given in fundamental units of newtons per square meter. Force is also given as 10 newtons, so no problem with that. 10 Newton. Area you don't know. So you put 1 over here, and we'll multiply the cross multiplication. So 2000 of A is equal to 10. You divide both sides by 2000. Then you can get the answer for A as 1 over 200. If you want, you can divide 1 by 200 and get the answer for the area. So I'll use that method, the simplest method. You divide 1 by 200, 0, once again 0, once again 0 for 1005. 0.005. Yes, this is the answer. 0.005 is the answer, right? 0.005 is our answer. So these are the answers for the MCQ questions, my dear children. Okay, so here there are different ways in converting this fraction into a this fraction into a decimal. But however, I have divided. If you want, you can multiply both the sides by 5 to convert into 1000. So 5 over 1000. That means also 0.005. Or else you can divide and get the answer. However, you will be getting the same answer. There is no problem in it. As we have substituted with the fundamental units like newtons per square meter and here newtons, our answer should be square meters. Okay. Right then. So these are the answers for the questions, MCQ questions given here, my dear children. Right, now let's go for the next one. So you have to write down the correct answers here. What is called as pressure? So pressure, it's really simple. You know what do you mean by pressure? Pressure is the force acting in unit area, right? Force acting on unit area. So you can write the answer, force acting on unit area. Force acting on unit area is called the pressure. Next one, write the equation used to calculate pressure acting on a solid. So it's really simple. Pressure is equal to force. You know it's perpendicular force. So I have told you several times within your syllabus, definitely you will be giving perpendicular forces. So don't worry about it. So it's okay to mention as force, right? Perpendicular force is the most accurate one. But however, it's okay to mention as force. So force, capital F, division area. Right? So the equation is equal to pressure equal force upon area. A car of weight 6,400 Newton has 4 wheels. There are 4 wheels. Each wheel has an area of 8 m squares touching the road. Find the pressure the car puts on the ground. So first of all, we'll calculate the total area. Total area in contact, right? Total area in contact. So the total area in contact is equal to 1 is 8, no? And there are how many? 4 wheels. So 8 times 4, my dear children. 8 times 4, right? 8 is the, right? 8 is the area that each wheel touching. each wheel has an area of 8 square meters. Then all 4 wheels have 8 times 4, 32 square meters. Now we need to find out the pressure. So pressure is equal to force upon area. Force is given 6,400. Area 32. So you can cut 32 1, 64 2. Answer is 200 newtons per square meter or 200 pascals. This is our answer. Okay, 200 pascals or 200 newtons per square meter. So how did I calculate? Once again, there are 4 wheels in a vehicle. It is saying that 4 wheels are there. Each wheel, that means one wheel, has a contact area of 8. So 8 times 4, altogether 32. There are 32, right? There are 32 square meters of a contact surface. Force upon area is the one which is referred as the pressure. So entire force exerted 6,400, area is equal to 32, 6,400 division 32 equal to 200 of pascals or 200 newtons per square meter. Then the next question, how much is 1 newtons per square meter in newtons per square centimeters? Let's see how to calculate this one then. So my dear children, listen to me quite carefully in this thing, okay? We know that 1 Newton per square meter is getting created by dividing 1 Newton by 1 square meter. This is equal to 1 newtons per square meter, right? Now we need to convert this thing into centimeter. So what I'm going to do? I'm going to do like this. 1 Newton. You can write 1 square meter like this. 1 meter into 1 meter. That's how 1 square meter is getting created. M into m to the power 2. Now convert meters into centimeters. How many centimeters are there in a meter? 100. Then 100 centimeters into 100 centimeters. Then you can get the answer as, so I'll mention like this. Then you can get the answer as 1 Newton over 100 times 100 is equal to 10,000 square centimeters. Now take 10,000. Now take the answer by dividing 1 from 10,000. Okay. So 1 newtons per square meter then getting equal to 0.0001, right? There should be 4 decimals as there are 4 zeros in here. So 0.0001 newtons per square centimeter. See, how did I convert? 1 Newton per square meter is equal to 1 Newton over 1 square meter. Then I have divided it into 2 parts as length and breadth. 1 meter into 1 meter creates 1 square meter. Then each 1 meter contains 100 of centimeters. 100 centimeter into 100 centimeters. 100 times 100 is equal to 10,000. So 1 over 10,000. altogether 0.0001 newtons per square centimeter. So 1 newtons per square meter is equal to 0.0001 newtons per square centimeter. Here the value is getting squared, no? So you don't need to you might confuse that we may need to divide it by 100 or by 1000. No. We have to divide by 10,000. Okay, we need to divide it by 10,000 in order to convert into square meters if square centimeters are given. Okay. So 1 newtons per square meter is equal to 0.0001 newtons per square centimeter. Okay. Right then. A person weighs 700 Newton and their feet have a surface area of 0.1 m squared. How much pressure is exerted? Now they're saying that their feet means both the feet, not foot feet. So both the feet are going to exert, so both the feet have a surface area of 0.1. So once again apply the formula P is equal to F over A. Force is 700 divided by 0.1. So here you need to multiply both the sides by 10 in order to convert into a whole number. So 7,000. So our answer is 7,000 pascals or 7,000 newtons per square meter. How come? Because we substituted it from the fundamental units, right? I told you several times, if you are substituting it with fundamental units, then for the answer also you will be getting fundamental units. Here, force is given from newtons and the area is given from square meters. Then definitely you will be getting the answer from pascals or newtons per square meter, right? Next one. How much is the force acting on a surface of 5 m squared when a pressure of 60 pascal is exerted? Okay, once again the same formula. P is equal to force upon area, right? So 60 pascal is the pressure, 60. Then force is the one which you need to find. Area is given 5. So you just need to multiply both the sides by 5, right? It's really simple. Just multiply both the sides by 5 to isolate F. So force is equal to 60 times 5, 300 of what? Newtons. How come it becomes Newton? Because pascal is given in here, which is the fundamental unit of measuring pressure, and square meters is given in here, which is the fundamental unit of measuring area. So if you are going to substitute with the fundamental units, definitely you will be giving or you will be getting an answer from the fundamental units of pressure, right? Pressure or force or whatever. In this place, we are finding out the force. So my dear children, you will be getting the fundamental unit of force, which is Newton. Okay. So 300 Newton is the answer. Explain what does 1 pascal or 1 newtons per square meter means. So you have to explain what does 1 pascal or 1 newton per square meter means. The meaning of 1 Newton per square meter is quite simple. What is that? 1 Newton per square meter means 1 Newton of a force is acting on 1 square meter of a area. 1 Newton of a force is acting on 1 square meter of an area. That is, what do you mean by 1 newtons per square meter or 1 pascal? Okay, so we can write the answer 1 Newton of a force. 1 Newton of a force is acting. 1 Newton of a force is acting on 1 square meter of an area. This is what do you mean by 1 pascal or 1 Newton per square meter. Upon an area of 1 square meter, 1 Newton of a force is acting. Right? This is 1 pascal or 1 Newton per square meter. Name the 2 factors that affects the pressure and the way it affects. Right. So the first factor, you know, force. I'll mention as the perpendicular force. So how it is acting? When increasing force, pressure increases. Pressure increases. Right? When increasing force, pressure increases. Then the opposite, when decreasing force, pressure decreases. Right? So when increasing force, pressure increases. When decreasing force, pressure decreases. This is the first factor. What is that? Perpendicular force. Then number 2 is surface area. Right? Surface area. So surface area, when increasing surface area, when increasing surface area, pressure decrease. Right? Pressure decreases as they are showing opposite relationship. So when increasing surface area, pressure decreases. Then in opposite, when decreasing, right? When decreasing surface area, pressure increases. Right? Pressure increases. So perpendicular force and surface area are the 2 factors. When increasing force, pressure increases. When decreasing force, pressure decreases. Surface area then, when increasing surface area, pressure decreases. When decreasing surface area, pressure increases. So these are the two factors that affects the pressure. Right, then we'll move on to the next question, my dear children. So still we are in the second main question. So the second main question, ninth question, what are the two units to measure pressure? The two units that we use to measure pressure. Okay. Number one, very simple, newtons per square meter. Newtons per square meter. Nm to the power -2. Then number two, pascals. Both the things are same. Pascal. Right? Both the things are same. So if you want, you can write the relationship 1 Newton per square meter is equal to 1 Pascal itself. Question number 10. Who is the great scientist that did experiments about pressure? To name a unit of pressure after him. Blaise Pascal was the scientist, right? So the great scientist Blaise Pascal. So Pascal, right? Blaise Pascal. He was a scientist from France. So scientist Blaise Pascal, right? Scientist Blaise Pascal was the person, right? He was the great scientist that did experiments about the pressure. To name a unit after him. Okay, Blaise Pascal. Right. So these are the answers for the second question, my dear children. We discussed 10 questions. Okay. Then the third one. Explain scientifically. So you need to explain these things scientifically. Number one, tractors have broad tires. Broad tires means this is to decrease the pressure. Tractors are used in, or tractors are moving on mud. So to avoid sinking, pressure should reduce. To reduce the pressure, they are using broad tires, right? So we can explain it like this. Tractors move on mud to avoid sinking. To avoid sinking and to minimize pressure. To minimize pressure, broad tires are used. Simple, right? So you know that tractors move on mud. If they are moving on mud, right, tractors should have an ability to minimize the pressure and to avoid sinking. So to avoid sinking, to minimize the pressure, they use broader tires. When the tire is getting broad, surface area is going to increase. When increase in surface area, what will happen, my dear children? Pressure is going to reduce. Okay. So tractors move on mud to avoid sinking and to minimize the pressure. Broad tires are used. Then the next one, iron nails have pointed tips. So upon having pointed tips, we can increase the pressure by decreasing surface area. So it helps to sink iron nails very quickly to a surface. Okay. It helps to increase pressure right. It helps to increase pressure. It helps to increase pressure due to less surface area. Due to less surface area. Therefore, nails will easily sink to a surface, right? It will easily sink to a surface upon small force. So it helps to increase pressure due to less surface area. Therefore, nails will easily sink to a surface upon small force, right? So this is the reason to have pointed tips. Soap can be cut using a thin wire easily. So I told you that when we are doing that experiment related to thin and thick wires, thin wires can be used to cut a soap very quickly because thin wires have less surface area which exert more pressure on the soap. So by applying less force, we can cut through the soap very quickly when we are using thin wires. Okay, so we can write the answer, my dear children. Thin wire has less surface area which exerts more pressure on soap. Therefore, it can be cut easily. Therefore, it can be cut easily. So, thin wire has less surface area which exerts more pressure on soap. Therefore, it can be cut easily. Then next one, heavy weights are used in road construction sites. Heavy weights are used to increase the pressure in order to press, right? In order to press and tie down those, construction stuff like metals and sand and rocks and those things to the ground firmly. Okay. So therefore, high pressure with a high force is applied. Okay. We need to apply high pressure with a high force. But however, in order to avoid sinking, it has a broader roller. Right? Heavy weights are used to increase the pressure so that the materials would press to the ground very easily. Okay. So we can write the answer. It helps to it helps to increase pressure and right, it helps to increase pressure and press materials to the ground easily. Right, so it helps to increase pressure, the pressure, right, and press materials to the ground easily, because upon having high force, high pressure is exerted, therefore these materials are pressed to the ground very easily. Okay, right. Elephants can walk on paddy fields easily, but bulls cannot. You know that elephants have broad surface area on their legs. However, bulls have less surface area. So therefore, bulls are exerting more pressure, while elephants are exerting less pressure. So elephants can easily walk on paddy fields, but bulls cannot. Okay, due to that change in the surface area. So we can write the answer. Elephants, right? Elephants have legs with high surface area. Therefore, less pressure is given to ground. But bulls have legs with less surface area. Therefore, high pressure is given to the ground. Right? So my dear children, elephants have legs with high surface area. Therefore, less pressure is given to the ground. Right? Less pressure is given to ground. But however, bulls have legs with less surface area. Over there high surface area, here less surface area. So if they have less surface area, then high pressure is given to the ground. So if high pressure is given, there is a possibility that they will not be able to walk quite easily. Okay, there is a possibility that they might not be able to walk easily because there is a possibility that they will sink within the mud. Then the next one, fish, birds have streamlined body shape. So streamlined body helps to create a greater pressure and travel very fast within the air or liquid medium. So it helps to cut and travel through the medium. Cut means here they can cut the streams of water or streams of air which is coming towards them. Okay, and to travel through them quite easily. That streamlined body shape is quite essential. So it helps to increase the pressure given by the body on those streams and to pierce and pass through. Okay, so we can write the answer. It helps to move. It helps to move through air or water. Right? So, as there are fish first, bird second, we'll mention as through water, air. It helps to move through water, air easily upon providing high pressure to water and air currents. Currents means streams. Okay. So it helps to move through water, air easily upon providing high pressure to water and air currents. Upon providing high pressure to water and air currents, okay, birds or fish can easily go through or move through water and air. Fish can easily move through water, birds can easily move through air. Right. Then the next question. Skating boards have broad foot while skates used by skiers have very thin foots. Right? So skating boards have broad foot while skates used by skiers, right, have very thin foot. So these skiers, these guys, you know that they are having very thin, like blade kind of a foot in order to increase the pressure. But however, skating boards, they are like this, no? This is the skating board. Now person is fixing his foot to here, then he is going to move on snow. Skating boards are moving on snow. However, skiers are moving, right? Skiers are moving on ice. So two different occasions. Here the ice should melt to create a slippery path. So to do that, pressure should increase. Okay. But in skateboards, pressures should decrease and they should have an ability to slip down very well without sinking. So those are the two cases in here. So we'll write down the answer, my dear children. Okay, let's erase this thing. Skiers, skates, apply large pressure on ice on ice to melt ice and to make slippery path. Therefore, thin foot is used to increase pressure. This is the first case. Then in the second, skating boards travel on snow to supply less pressure surface area of the foot is high. Surface area of the foot is high. It helps to avoid sinking in snow. Right. So, skating boards travel on snow. To supply less pressure, surface area of the foot is high. It helps to avoid sinking in snow. So, these two are traveling in two different places. That's why one exerts a large pressure and ice is going to melt and make the path slippery. Okay, right? In the second case, skating boards travel on snow, so therefore to supply less pressure, surface area of the foot is high and it helps to avoid sinking in snow. Right? So these are the explanations for using these two in two different occasions. Skiers use, right, thin foots, but skating boards have broad foot, right? Then we'll go for the next question. It's difficult to cut using a blunt knife, but easy to cut using a sharp knife. So I told you this thing earlier also. Sharp knife, it has a thin surface area, less surface area. So upon less force, we can cut. Blunt knife has a greater surface area than the sharp knife. So it's difficult to cut. So we can write, when surface, or we can say blade, when blade is sharp, surface area is less. It helps, it increases the pressure. Therefore, is easy to cut by using a sharp knife. Right. So when blade is sharp, surface area is less. It increases the pressure. Therefore, it is easy to cut by using a sharp knife as it produces more pressure. Right then. So these are the scientific explanations, my dear children. So put a tick or cross for the given statement. So if it is correct, you have to put a tick. Wrong, then you have to put a cross. Number 1, pressure is the weight acting on a surface area. Pressure is the weight. Actually, it's not the weight, my dear children. It should be the force, right? So this is incorrect. It's not the weight. Let's imagine that by keeping a weight, you are also pushing it. So there's a different case, no? Weight is going to give out an impact on the pressure, but if you take the weight, this weight is just a factor that's going to change the pressure. Okay. However, with the weight, we have to consider the other perpendicular forces as well. So, when making the pressure, other perpendicular forces should come into consideration, not only the weight. So, my dear children, pressure is not the weight acting on a certain surface, but it should be the force acting on a certain surface. Pressure do not have a definite direction. Pressure do not have a definite direction. That is correct. I told you that pressure is a scalar quantity. So, it is correct. Next one. Pressure acts all around the surface to all directions. That is also correct. That is why it is not having a definite direction. It is correct. Pressure is a vector quantity. Incorrect. Pressure is a good example for a scalar quantity. As there is no direction, it is a scalar quantity. Rough or smooth nature of the surface affects the pressure. No, not at all. The surface area is going to depend the pressure, not the rough or smooth nature, right? Surface area is the one which is going to help. Okay. Then, gravitational force of earth do not affect the pressure. That is also correct, right? Gravitational force is not going to affect the pressure, right? So, pressure is depending on two factors, force and the area. Then the next one. Pressure is measured from newtons per square centimeter and it is also called as pascals. Absolutely incorrect. Newton per square centimeter. No. Newton per square meter is the one which is referred as pascals. So, it is incorrect. Next one. Pressure do not change when changing the weight of an object. Pressure do not change when changing the weight of an object. That is incorrect. When changing the weight of an object, pressure does going to change. When increasing the weight, pressure is going to increase. When decreasing the weight, pressure is going to decrease. Okay. But however, pressure is not the weight placed on a certain surface area. Force placed on a certain surface area is correct. But however, my dear children, pressure is going to change when changing the weight of an object. Okay. As it is also count as a force. Next one. Mass is not a factor that affects the pressure directly. Correct. Directly mentioning no. So, it is absolutely correct. Mass is not a factor that affects the pressure directly. Correct. It's not getting directly affected. Directly affecting only two factors, force and the area. That's it. Pressure do not change when increasing surface area. Pressure do not change when increasing surface area. Incorrect. Pressure change when increasing or decreasing surface area. Why is that? Because that's a compulsory factor in defining the pressure, the surface area, right? So my dear children, these are the answers for the final one. Okay, right. So I hope that you got a good knowledge, a sound understanding about the concept called pressure. So we did several exercises within this lesson to understand the concept called pressure. So my dear children, we came to the end of the lesson after finishing out all the exercises. So I hope that you got a good knowledge about the lesson pressure. So I hope to meet you from our next chapter, 6th chapter after this one. Okay. So until then, it's time to say goodbye. We'll meet you with the 6th chapter then.